Alright guys, how's it going? My name is Sergey and today I'm going to discuss the stack data structure, which is a very common and pretty simple in my opinion data structure, but despite being simple, it is very powerful and pretty useful in many programming applications and in system programming as well. If you are preparing currently, for instance, for a job interview, for a coding interview or something like that, this information hopefully might be useful for you. So without further ado, let's get started. Alright, I'm gonna write this data structure and related algorithms using the C programming language. And by the way guys, I've been working for several years, I would say, with a couple of different languages such as Java, JavaScript, C, C++, mainly, I would say, because of my background in mathematics, but it doesn't it's not related to what we're gonna discuss today. But anyways, I'm gonna use the C programming language, but really you can use whatever language you prefer to use when working with not only with data structures, but when writing your applications and things like that. Alright, so I'm gonna use VS Code, the VS Code editor. You can use whatever editor you want, and to get started with, I'm gonna show you a little picture which I found on the internet, and this data structure, the stack data structure, follows the principle of LIFO or LIFO. I'm not sure exactly how to pronounce it correctly, but anyways, this imagine a stack of plates, for example, where in order to get to the bottom of the stack of the plates, right, you should first of all remove all of the all of the top plates in order to get to the bottom of the stack of the plates. And this same principle is applied to the stack data structure, where each element which is gonna be put on top of the which is gonna be put the last, I would say, into this data structure, right, into this container. I would say we can represent this data structure as a container where the last element put at the top is gonna be removed, the first one, right? So in the stack data structure, we can perform many different, no, not many, some different operations on the stack data structure, which we're gonna discuss using the C programming language. And I'm gonna start with absolute scratch. Alright guys, and I'm gonna comment my code as much as possible so that you might be able to refer to it in the future, of course, if you wish to do so. Alright, so let's get started. We're gonna say stack data structure using C programming language with arrays, I would say. So, and I'm gonna explain you what I mean by that. So implementing, there is a couple of ways, at least as far as I know, to implement this useful data structure. First of all, you can use arrays, which is a special data structure. In, I don't know, maybe it could be considered a basic data structure, maybe not, but anyways, this data structure is a data structure where every element of an array, of a particular array, is going to be stored at a contiguous memory location, memory block. And we're going to use exactly this data structure in order to implement our stack data structure, of course, but it's not the only way possible to implement stack data structure, because you can use linked lists data structure to implement stack data structure algorithms. But I think that in the next video, maybe the next series, I'm gonna show you how to implement this data structure using a linked list, which is gonna be pretty cool in my opinion. So, but here we're gonna use arrays. All right. So first of all, we should be able to represent our data structure, and in the C programming language, we can use structure. We can use the data structure, which I'm gonna define down here. But first of all, we should include in the C programming language, we should include a couple of directors. I'm gonna say include stdio.h. Also, I want to include std lib, I believe, .h, in order to work with the first one is gonna be useful when working with a standard input output, and the second one is gonna be needed when we are using a dynamic memory application, and I'm gonna explain what I mean as we move along. All right, first of all, we should define our stack data structure. All right, stack data structure using struct. All right, so I'm gonna say struct. We're gonna name it, S, maybe just S. All right. So, and we're gonna need a couple of elements of this, a couple of components of this data structure. As I already pointed out, we're gonna use an array to represent our data structure. For the sake of this example and for the sake of simplicity as well, we're gonna assume that all our elements are gonna be the type of integer. All right, so we're gonna say int maybe stack, right? And we'll need to specify the maximum number of the elements of our array, I believe, and we can define as a constant up here. Define. I'm going to say define. Well, let's say it's max. It's going to be equal to 5, for instance. It's going to mean that we'll have 5 elements of our array, but the number can be pretty much anything really, but it's gonna be 5 to get started with. Alright guys, it seems like we're having a couple of small issue. Alright. Alright guys, seems like we're having an issue here. I should say define our constant like this, I believe. Yeah, and that should do it. So alright guys, next we're gonna discuss some useful and plausible available methods, I would say, which we can implement within this data structure, right? First of all, we should be able to create an empty stack, right, to get started with. And if we have an empty stack, our top element our top element so our top element is gonna be -1 just to get started with, and if we so that we'll be able to figure out if we have the top variable is equal to -1, that will mean our stack is empty. Alright, so and to get started with, so we're gonna say function forward declaration. I can type today, sorry about that, guys. Prototype, just prototype our functions. Alright, first of all, we should be able to create an empty stack. Next, we should be able to figure out if our stack is empty or not. So we should be able to check if the stack is empty. Next, we should be able to figure out if our stack is full. If the stack is full, alright. Next, we'll have to add any I would say push, and if we add a new element onto the stack, it's gonna be called, this operation is gonna be called the push operation. Alright, push a new element on the top of the stack, I believe. Next, we should be able to pop, and in other words, we should be able to remove an element, and the only way we can do it is by removing it from the top of the stack. Pop the top element from the top from the stack. Okay, and yeah, and lastly, we should be able to print all our elements of the stack. Okay, print the stack. So that's our strategy, and so let's get started. So first of all, in order to create an empty stack, we should be able to say that its top element is gonna be equal to -1. So let me show you a little picture which I also found on the internet. So here we can see that if we have an empty stack, our top element, right, is going to be equal to -1. All right, so that you guys will be able to understand this data structure a little bit, you know, so that you are not confused with you know, this data structure. All right, first of all, we create an empty stack. So we're gonna create a function which is gonna be type of void. Because it doesn't return anything. So, and in case you're not familiar with the C programming language, I mean that just you know, a function that doesn't return anything. If you are coming from JavaScript, for example, or maybe Python programming language or anything like that, I'm gonna say void create empty stack, I would say. So we're gonna list a couple of parameters of our function. I would say one parameter only we're gonna need over here. So and we're gonna say our empty stack, we're gonna pass our struct to this function. Alright, struct. In C we're gonna say struct. So struct. So and it's gonna be a pointer to our structure. It's gonna be a pointer to our structure, guys. And if you are not familiar with pointers, you know, you might check it out on the internet, or I might create a separate video where I thoroughly explain what a pointer is. And but generally speaking, a couple of words, I would say that pointers, they deal with dynamic memory allocation. And if you coming from different programming languages, from higher programming languages, more modern programming languages, I would say, such as JavaScript, for example, or maybe Python, you of course you won't be able to know what pointer is, because those languages, they handle this dynamic memory allocation automatically, but in C is the programmer responsibility to handle this this memory, dynamic memory. And but being able to manage this dynamic memory manually, I would say, is gonna benefit you greatly, in my opinion, because this way you will be able to have direct access to your memory, whereas while working with higher more modern programming languages, such as Python, for instance, you might not be able to handle your memory. All right, you might not be able to understand what's going on under the hood, I would say, and that's the main disadvantage of using those languages. But they are of course like great languages. But anyways, let's carry on. Yeah, guys, we should say struct s is so we probably should have named it st or something like that. It would be, I think, a little bit more cleaner and a little bit more readable. But here we can use this param, for instance, to represent our struct. So next we should be able to check if our stack is empty or not. All right, and in order to do so, we can use the bool type, which is not included in the C programming language by default, by the way, in case you didn't know that. And we can use the standard library std bool, I believe, yeah, to deal with the bool type. We're gonna say bool is empty, I believe. We're gonna list our struct here. Alright. The next operation is gonna be checking if our stack is full or not. Is full. And we're gonna list our structure as well as the parameter for our function. So guys, you can type today struct. Alright. Next, we should be able to push a new element on top of the stack. I think that is gonna be a function with the type of void, I believe, because it doesn't return anything really. All it does is pushing a new element onto the stack. That's it. Push element. Alright, struct st. We're gonna take a couple of parameters. Struct. Alright, struct and element. It's gonna be type of int for the sake of simplicity. Element. And next, we should be able to pop element void pop element. Let's call it pop element. It's gonna take our structure. And lastly, finally, we should be able to print our stack onto the screen, right? Print stack struct st yes. All right, and that's our functions. So let's scaffold out our main function. All right, yep, and here we can start. So I'm just gonna comment my code as much as possible for the sake of understanding for you guys, of course. Alright, so function definition. Alright, and yeah, first of all, we should be able to create an empty stack. We're gonna say void create empty stack. Okay, create empty stack. It's gonna take struct. Alright, so first of all we should check if the top is equal to -1, then our stack is empty. Alright, if so, and in order to access the members of this struct, we can use the arrow syntax. Alright, if st, so I should have say not st, is if s arrow, sorry guys, top is equal to -1, not null, not 0. That means that the stack is empty, right? So I'm gonna say print f, the stack is empty, right? Yep, and we're just simply gonna return. Alright, so next we should be able to figure out if our stack is empty or full, right? Alright guys, we should be able to figure out if our stack is empty or not, and we're gonna say bool is empty. We're gonna pass our structure. For some reason I can't type struct properly. Alright, so how are we gonna be able to figure out if our stack is empty or not? So of course it will be empty in the case it's gonna be empty in the case if the same above here is true. And guys, seems like I made a small mistake over here. We shouldn't check if our top is equal to -1. We're just gonna assume that. Yeah, stupid me, sorry about that guys. We're just gonna say that s arrow top is equal to -1. This way we make sure that our stack is empty to get started with, right? And here we should check, and probably we should have removed our comments here. Just assume that our stack is empty to get started with, right? Okay, and here we're gonna say check if the top is equal to -1. If s top is equal to -1, that means we're gonna say that the stack is empty. right? And yep, and just print a new line. All right, if this is the case, I mean, no, I think that we can just return true. Yep. Else return false. All right. And here, next we're gonna check if our stack is full. Struct steam. We're gonna check if the top is equal to max minus 1, and just to remind you guys, max is basically it's gonna be the length of our array, right? And if our top index, right, index I would say, is gonna be the size of the array, that means that our stack is full and we can't push another element on top of the stack, because it's not going to be possible. We're going to have stack overflow, right? So we're just going to say if s top is going to be equal to max minus 1, that means that our stack is full, right? Return true, else return false, and that's it. Alright guys, I think that we can stop here so that you have a little break, and in the next video we're gonna implement the next 3 functions in order to implement our algorithms in the stack data structure. And thanks for watching, and I'll see you next time. Bye bye.